Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome back. Today we're going to be looking at solving quadratic equations by factoring. The difference between my factoring video and this video is now we're going to have equations, therefore we're going to have an equal sign. And I'm also going to be relating the factors to the graphing if you didn't pick up on that before. First of all, we actually have to understand kind of what's going on in the background here. So let's just think about what happens when we have something times something else, whatever A happens to be, whatever B happens to be, and the product is 0. Hence, we're going to be talking about the zero product property. Because mathematicians are not known for ingenuity whenever they name things. It's a product, it equals 0, zero product property. So in order for this product to equal 0, either A has to equal 0 or B has to equal 0, or they both could equal 0. We do not do this product for any other thing, any other number, because let's say A times B equaled 1. Well, now there's 1,000 ways for this to happen. You could have 1/9 times 9, 2/3 times 3/2, etc. Anything times its reciprocal. This is not efficient. But the zero product property, we are guaranteed that one of the two factors equals to 0. So let's go ahead and let's look at a problem. And of course they're quadratic, so the highest exponent is going to be a 2. If you do not have an exponent of 2, this is not a method that you could utilize. So let's start off with x squared plus 7x plus 12 equals 0. If we were to look at this, notice I just put in the equation on the left-hand side. On a Desmos equation, we're noticing that it crosses the x-axis at -4 and it's crossing the x-axis at -3. So let's keep that in mind, that the x-intercepts, where the ordered pair is -4, 0 and -3, 0. If I were to come back and put this in here with the equal sign, now I have two vertical lines, one being at -4 and one being at -3. So something's up with this -4 and -3. We will come back to that later. In the factoring video, we learned that if we just look at this part, that we have a product of two binomials. There's not a greatest common factor. So we can look at this. A is 1, so we don't have to worry about boxing it out. So the only way to make x squared is x times x. Everything is positive, so we know everything's going to be positive. 12 is 1 times 12, or 2 times 6, or 3 times 4. But we know that we're trying to get the outside and the inside to make this 7x right here. So 1 and 12 is not going to add to 7, 2 and 6 adds to 8, but 3 and 4 does add to 7. So we have 3 and we have 4. So now what I see is a product equal to 0. Just like before, we had a product equal to 0. Except now instead of A and B, I have a quantity x plus 3 and a quantity x plus 4. So that means either x plus 3 equals 0 or x plus 4 equals 0. Now I have two linear equations and I can solve my linear equations. Subtract 3, and over here I'll subtract 4. Now let's just double check what's going on here. Let's test out -3. -3 squared plus 7 times -3 plus 12. Hey, that worked. It equaled 0. My other answer that I got was -4, so let's verify that one. -4 squared plus 7 times -4 plus 12. That also happened to equal 0. Therefore, the zeros and the x-intercepts are talking about the same x values. Some places also call it the roots. -4 and -3 were the x values that made it equal 0. So could you solve these by graphing? Absolutely. You definitely could. However, sometimes we get irrational answers or fractional answers, and so graphing is not always our best bet. Also, sometimes you have to show your work. And actually, I can factor really quickly, and it's a lot faster for me than graphing. So if we get really amazing at factoring, the graphing is just a little extra and redundant. Okay, so can you look at a graph and get the answers? Yes. Will you always have that opportunity in your classes? No. So keep that in mind. Also, I know a lot of college classes require you to show work, so this is very important. Now, could you look at your graph and say, hey, here's where it crosses. Since it crosses here, this has to be my factor and this has to be my answer? Yes, absolutely. And that's actually going to be something we look at later on in this video. So let's look at this particular problem. This is quadratic, but it does not equal 0. We cannot apply the zero product property if it does not equal 0. So our first step, make it equal 0. I'll subtract 24 to both sides. Okay. Now I'm going to factor x and x. All right, what are the ways to multiply to 24? Well, we have 1 and 24, and that's a positive 5, so it'd be 24 times -1. That adds to 23. So we'd have 12 and -2. They would add to 10. Okay. 8 and -3. Hey, that makes 5. They add to 5. So +8, -3, it equals 0. So now that it's a product that equals 0, I'm going to set each factor equal to 0 by the zero product property. Subtract 8 to both sides. Add 3 to both sides. So I have two solutions. X is either -8 or +3. You could choose either and it would work. Again, you could double check that by graphing, which would be a great way to solve this if you chose to do so. In this example, we see that most of the terms are on the right and the positive 2x squared is on the left. I personally prefer to factor with a positive lead coefficient, meaning the number out front in front of the quadratic term is positive. So when I make this equal 0, I'm going to move everything to the side of the positive 2x squared. So I will add 9x and subtract 5. And this time I'm going to go ahead and box it out because this one has a lead coefficient that is not 1. If you don't know what I mean by box it out, go back and watch the factoring videos. All right, our other two boxes need to multiply to -10 x squared and add to 9x. So it multiplies to -10 but adds to +9. That would be 10 and -1. GCF and GCF, closest box is positive. GCF GCF, closest box was negative. So that gives me 2x minus 1 times x plus 5 equals 0. Now that it's factored, I can apply my zero product property. 2x minus 1 equals 0, or x plus 5 equals 0. So 2x equals 1, x equals 1/2, x equals negative 5. So this time we got a fraction instead of an integer. And that happens a lot when you get a lead coefficient that is not 1. So we had 2x squared equals 5 minus 9x. And I have it graphed here on Desmos. And we can see here that it is numbered, where 1 would be, where 2 would be. We can see that it's crossing, but unfortunately, it doesn't always let us have those numbers. So anytime it doesn't let you have those numbers like that, that's when you go back, you move everything to the one side, and you delete the equal sign. What I mean by that is 2x squared plus 9x minus 5. And you'll notice that it crosses the x-axis at the same place those vertical lines were. And generally there, if you're utilizing Desmos as a way to verify, it will show you the correct answers as well. You might notice that the signs here are the opposite of the signs here. And the reason for that is we had to subtract 5 to cancel it out. It's because this has to make the parenthesis equal 0. So it's very important our solutions make the parenthesis equal to 0, hence the zero product property. Okay, x squared equals 8x. So this does not equal 0. You'll notice the c value is missing. There's no constant, there's no plain old number. Well, one thing we sometimes forget is this first step in factoring is to factor out a GCF. These both have an x, so I can reverse that distribution process instead of reversing the FOIL process. Keep in mind that this now reads x times x minus 8, so technically it's right there. So our zero product property is to set each parenthesis equal to 0. So x is either 0 or 8. Here we have 3x squared minus 12 equals 0. And I know there's other ways to solve it. I'm focusing on factoring today, so please bear with me. So first of all, the GCF is 3, which would leave you with an x squared minus 4 equals 0. X squared minus 4, that's that special pattern. So x plus 2, x minus 2. Again, we talked about that special pattern in the factoring video. And then we set each parenthesis equal to 0. I say that, but the only ones that can equal 0, 3 cannot be 0. 3 is a number. So setting this equal to 0 has no bearing on our problem because it's always going to be 3. So the only quantities that can be set equal to 0 are the ones with a product in them. And we'll solve that and we'll get negative 2 or positive 2. Now, could I have divided both sides by 3 and just had x squared minus 4 equals 0? Absolutely. And then I would have gotten the same 2 answers. If your exponent is 2, you're trying to get 2 answers. That's a big, big, big thing. So let's look at x squared minus 14x plus 49 equals 0. Okay, so we're going to factor. What makes x squared? X x and x. What multiplies to 49 but adds to 14? Well, we could do 1 times 49 or 7 times 7. Now you might say 7 times 7 works because 7 times 7 is 49, but 7 plus 7 is positive 14. I need negative 7 times negative 7 to make that negative 14. Now, if you'll notice, this is the same parenthesis. It's been repetitive here. That's going to play an important role because I can set it equal to 0, and I'm going to get the same answer. I'm getting two answers. There just isn't two unique answers. So what's going on here from a visual standpoint? You had x squared minus 14x plus 49, and it equaled 0. I see, instead of the parabola coming down like it normally does and crossing the x-axis twice, it only touched once. So this is an example of one real solution. Normally we get 2. This one just happened to give us 1. Now, do all problems have answers? No. No. Because not all graphs have x-intercepts, not all equations have answers. So again, our zeros or our roots are our x-intercepts. They correspond to the graph. If you don't have an x-intercept, it doesn't equal 0, ever. So we could say x equals 7 is our only answer, and it is technically a double root. Some books use the word multiplicity. That just means used twice. So as you solve by factoring, step 1, you want to make the equation equal 0. Step 2, you want to factor. Step 3, you want to apply the zero product property. And remember, this is only if the highest exponent is 2. Meaning if it's quadratic. And then 4, you can verify your solutions. Usually in quadratics, it's not such a big deal, but as you move through different equations, that's always a good idea when you're working with different types of formulas, is that sometimes we get roots that do not work. Now, this method does not work 100% of the time. This method only works when you have rational solutions. Now, I find my students forget the word rational a lot, so I'm going to bring out that. There's our root word, ratio. Ratio is like A to B. It can be written as a refraction. Now you might have said, hey, the answer a while ago was 7. Well, can't 7 be written as 7 over 1? Absolutely. So there we go. We can do that. It happens. Now we're going to also reverse that process. I'm going to give you some ordered pairs, and you're going to give me the equation of the parabola, which would be a quadratic equation. So we are going to write an equation. And I'm just going to go ahead and give it to you in the form of a t-chart. -5, 0, 2, 0, and 3, 4. Now, I didn't tell you any of those were the vertex, and if you looked at some of the previous problems that we've done, we put it into standard form and we had to work it out a really long way. However, they're giving us the x-intercepts right here. Okay, making a rough sketch. Left 5, up 0, right 2, 0, and over 3, 4. Okay, so it's got to come down and it's got to come back up. We just don't know where the vertex is. I don't want to do that whole ax squared plus bx plus c pattern that we did in a previous video. We do not know what a is. Who knows? However, we do know that x equals -5 and x equals 2 are answers from the factoring. Well, if x equals -5 is an answer, then x plus 5 had to be a quantity. If x equals 2 is an answer, then x minus 2 has to do that because they both made the problem equal 0. And there could have been some kind of a value up front. How are we going to test for the a value? That's where that third point comes in. So when I substitute 3 for x, it's supposed to equal 4. Okay. Why did I write 5 or 4? No, I'm supposed to write 5. There we go. So we have a times 8 times 1 equals 4. So 8a equals 4. So a equals 1/2. Okay, I have an equation now. 1/2 x plus 5, x minus 2. There we go. I will tell you that if they tell you a equals 1 and it has a x-intercept of 1.5 and 3, a lot of you are going to go straight to putting 1.5 in, and we only use integers in our parentheses or our quantities. 1.5, while it's rational, is not an integer. So remember, 1.5 is also known as 3/2. So one of the answers is 3/2, one of the answers is 3. We don't want this fraction, so to get rid of the fraction, I'm going to multiply both sides by 2. And then I'll subtract the 3 over. And here I can just subtract the 3 over. So now I have my two quantities that make this 0, 2x minus 3 and x minus 3. So if you have the x-intercepts, you have the answers, and you're just working back to the problem. If you can factor, solving by factors is one of the easiest things you can do.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.